All right, so I think we're gonna get started. Sorry about the delay. There's more people here than we thought there would be. Welcome to the first cybersecurity technical workshop of the semester. I'm Larry. I forgot to announce myself during the GBM, but I'm Larry. I'm the president. I've been here 4 years, and today I'm going to be talking about Unix or some Unix, Linux. Technically, they're not the same thing, but you can kind of think of them as the same thing. Although don't tell Richard Stallman that. So today I'm going to talk about Unix, basically like the foundation for a lot of computing that happens in the real world. Basically, although today won't be completely directly related to cybersecurity, knowing this is kind of the first step to knowing a lot about not just cybersecurity, but CS in general. So it's a very nice set of skills to have, and it's something that you don't really get in a very concrete way from school. And that is what we are trying to teach you today, really just how to work with Unix, what it is, what its purpose is, and some of the cool things you can do with it. And from here, you will be able to springboard onto basically any subfield, because it's kind of the basis for everything. For a lot of things, maybe not everything. But yeah, very quickly, if you guys feel like you already know Unix or Linux and would like to do something more advanced, we currently have the Linux rootkit talk, which is like a form of advanced malware, over in the CS makerspace. You just go down to Halt and look on your left. So if at any point during this talk, battery died, it's whatever, I can project. If at any point during this talk you feel like you already know the content that I'm going over, feel free to just stand up and go over to the other area, the other classroom, and then sit in on that talk instead. We should be releasing both of the talks and their slides anyways after today is done. We might have a delay for the rootkit talk, but regardless, you will be able to revisit all the content we're going to cover today anyways. But let's go. So one quick disclaimer, I'm going to cover kind of a lot of content today, so this might feel a little bit overwhelming, but that is perfectly normal. CS is a very wide field, and it's a lot of computer science is built upon a lot of different frameworks, a lot of different technologies. And while you're learning each individual part, it might feel very overwhelming in the moment, but as you revisit it over time, you'll start to kind of build together that like kind of understanding of how everything interacts with each other. So if this is your first time interacting with something that like outside of class for CS, don't feel overwhelmed. It is completely normal to kind of like feel like there is a lot to get through. And of course, we're always around to help you guys if you feel overwhelmed in any way. And now, finally, let's get started. Sorry about the delay. So for the first 5 minutes of this talk, I'd like everybody here to quickly turn to your neighbors and talk about your understanding of Unix or Linux. I'm sure you guys have all heard in some capacity of Linux. So talk to your neighbors, what actually is Linux? What do you understand about Linux? And then if you don't really know much about it, like what have you guys heard about it? So yeah, we'll take a little less than 5 minutes for that. Feel free to move around if you don't have many neighbors at your table. Or you can find it online Unix channel. There's a lot of like emulators out there.
I use them, so
yeah. Oh gosh. You might have to search it up because I've never worked with this.
I think they want me to do is change it.
It might be from this. You would have to search it up. But so what did you guys talk about during that discussion? Like, who here already knew what Linux was? Like, could define it before coming to this talk? Raise your hands. Okay, so not too many. Who here wants to give their best shot of what Linux is? Any volunteers? No wrong answers. Going once, going twice, all right?
It's like a combination for us three said it's an open source OS which is used by basically every single company, like the back including servers and basically everything that's not Windows is kind of
Yep, basically exactly that. So if for people who didn't hear him, he said that Linux is a OS, so that stands for operating system. And those companies will use Linux in their backends to host their servers and like other resources if they're not using Windows. That's perfectly correct, exactly correct. So Linux is, yeah, like you said, a operating system. It was first developed in the 1960s, so it was one of the first things that came out. And specifically, it started as the operating system Unix, and then became a couple of other operating systems with time. For example, if you guys are using a Mac, Mac is a derivation of Unix. It uses Unix as its baseline. So actually, if you didn't get the VM set up for today, if you're using a Mac with Mac OS, you still have a Unix environment, and you can still do from your terminal a lot of the things we're going to be covering today. And then also, another operating system, or I guess lineage or line or family of operating systems that came from Unix is also the Linux operating system. That's like why people say Unix is different from Linux, because Unix is kind of like a grandfather of Linux and a lot of other operating systems. And here are some like specific examples. If you guys have ever heard of Ubuntu as like the, I guess, prototypical operating system that uses Linux, it's downstream of the Linux system Debian, and so like first Linux or like Unix was made, then the derivation of Linux Debian was made, then Ubuntu was made as a derivation of Debian. So there's like a whole family of different operating systems that kind of split off from each other. And that's a very, very simplified list, because the actual list of operating systems that derive themselves from Linux is kind of insane. And you have, if you guys have ever heard of like Arch Linux user, like there are some very, very niche Linux distributions out there as well. Yeah, it gets huge. This was also a simplification. This is the actual taxonomy of Linux distributions. So why does Linux matter? Well, even if you don't go into cybersecurity, Unix is used basically every single day by software engineers and IT professionals and everyone to use tools in computing like GitHub, Docker, and a lot of different other environments or tools or languages or frameworks. The reason why a lot of these companies will use Linux is that it's open source, it's typically more lightweight and more specializable. So it makes more sense for a company to run, for example, a server on a Linux server or a Linux machine rather than a Windows machine, because Windows has a lot of bits and bobs that you don't necessarily need, especially if you're trying to do a lot of things at an efficient scale. And on top of that, actually, Unix OSs might seem like this very technical thing that not many people use, at least for like daily consumer use, but it's actually used in millions and millions of mobile devices because Android is based off of Unix. And also, of course, Mac OS uses Linux as well, et cetera, or Unix, not Linux. So what does Unix actually entail? So Unix is an operating system. It's kind of the software that your computer uses to be useful to you. So like it's the software that manages running applications or like taking in input and output from different hardware on your computer, like your screen or your headphone jack or your USB ports, et cetera, et cetera. And the operating system has to manage all of this so that your hardware can actually run useful things to you, such as software. So like your browser, your video games, et cetera, et cetera. So how Linux handles this is with something called the kernel. So the kernel is the core of the Unix operating system. It's also present like basically every operating system. Basically, it's kind of the boss of your computer. Because if every single application, everything that's running on your computer had full access to everything on the computer, so like the memory, the hardware, the screen, whatever, if one of them goes malicious or malfunctions, like crashes, then it could potentially screw up the entirety of your computer because it has access to everything. So we protect against this by having this like guard in place called the kernel. So the kernel, what the kernel does is that it allocates all of the resources on your system. So if a application software wants to use your headphone jack, because that's hardware, it has to make a request to the kernel saying, hey, can I use this hardware piece, so the headphone jack, for this purpose? And our kernel will be like, okay, sure, or no, you're not allowed to do that. Same thing goes for allocating memory, if you guys know what that entails, and a lot of other functions on your computer. So your kernel is like the big boss, while that like allocates everything, and manages everything, and allows people to do stuff and not, while like the rest of your operating system is kind of like the factory that tries to create services or like create products. And that's, if you guys have ever played like a Riot Games game, like a League of Legends, God forbid, or Valorant or something like that, if you guys have heard of, what was it, Vanguard anti-cheat, I think it was? That's an example of a kernel level anti-cheat. So it's an anti-cheat that you give kernel level permissions to, so that it can monitor everything. It has like all the permissions on your system. Because of this, it's also very, very dangerous. And if a hacker finds a bug in Vanguard anti-cheat, they basically have full permissions to any computer it's on, because it has kernel access. So that's why the bug bounty, so like the money that Riot Games will pay you if you find a bug for Vanguard, is in like the hundreds of thousands and billions, because it is that important of an anti-cheat. It has that many resources or permissions that can do that much stuff. So this basically goes over what I just said. Basically, the kernel is the first thing loaded when you boot up the computer. A little bit of a simplification, but you can think of it as like the first relevant big like software piece booted when you open your computer, and then it uses processes which have like which are like kind of like your applications. Each of them has a unique ID on your system, and kind of like manages the resources we give them and the hardware input output that we give them. So on top of that, we have what's called the shell. So if you guys have ever used a terminal, we kind of use these things interchangeably, shell and terminal. Basically, your shell lets you run specific commands that interact with your computer. And so this could involve things like listing files in a directory. It could involve like running something. And sometimes this can involve communicating with your kernel if you need to do something that requires extra permissions. It's also called like a CLI. That was the third term I was looking for. So think of like the shell as kind of like a floor manager. It like interacts with like the big boss to get permission to do things to control the workers. So you're kind of like, when you use a shell, you're kind of directly interfacing with your computer. So the default shell of Ubuntu, and this goes for a lot, not all of Linux distributions, is called Bash. Basically, when you open your IDE in your shell in your VM, it will open as a Bash shell. And then in your shell, I'll show this off actually because I'm running a Linux system. Once you open your shell, you will get into this command line interface. I'm gonna try and zoom in if I can. There we go. You come out to this line of text because the shell is like kind of like a text base. It's not like super graphical. And then you can type in commands and like run stuff. So for example, I can press this command. I'll tell you guys how to run these commands later. I run that command and I actually list all the documents and directories in the current directory I'm in. If I run this command, I figure out where I am. So I'm in actually my home folder for the later user. If I do this, I can actually read out the contents of the stove that's empty. Sure, I don't have anything bad that I can accidentally share here. If I want to, let's let's see, CS2, you guys can see my CS220 homework. C3, CS220. Project, CD project, I can't see, hold on, let me do both hands. CD project 1, cat, tsconfig, yeah. So you can use that cat command to like see the contents of different files on my system. So it's basically like a text-based way of running like text-based commands to do stuff that you would otherwise with like your GUI on your operating system. And this might not seem that impressive, but the thing is that your GUI is kind of like an abstraction that like lets you do all the things like a normal generic person, like your grandma interacting with your operating system might need to do. But with the terminal, it can be very specific and do things that you wouldn't be able to do just with like your actual graphical interface, like in your file manager, for example. And we'll get into that very soon. So if you go back into our here, so additionally, there's this thing called bash files, which allows you to chain together different commands and do some other logic when you run these commands to do more complex compound things, such as like printing out the contents of a couple directories, or like searching a few directories, et cetera, or searching based on variable input. And these are called .sh files. So now that I've talked about the Linux, how Linux works and how the shell works, first, does anybody have any questions about what I just went over? Any questions? Raise your hands. Any points of confusion? No? Okay. So what I want everybody to do now is to open up your terminal. If you didn't get your VM set up, look on with a partner for now, just somebody next to you, and type the following commands into your shell. What did each command do? And discuss this with the people around you. If you're running Mac OS, you can also do this without a VM if you didn't set it up already. So let's take a minute or two to do this.
It just says not found. Yeah, me too. I definitely have to install that. Or we have to add it. Well, I have to. I don't know.
Everybody good? Okay.
Well,
Yeah.
LS was like, and then UMI told me who I was.
Oh, did you follow the You had a better download link than there's a different ones you For now, just like work with somebody next to you. Yeah. Alright, does anybody want more time for this exercise? Everybody good? Okay, so who can tell me what came up when they ran LS on their machine? Yes.
The stuff on my C drive?
Yes, good. Where you want Windows? Okay, it means the same thing on Windows. This is gonna stop working after this command. Yeah, basically it shows you the stuff in your current directory that the shell or your terminal is pointing to. Who can tell me what came up when you ran who am I? Yes.
You are the current Linux distro,
Not quite, although I see the confusion. So when you run who am I on the machine, I come up as Larry.
Oh, it's the user.
Yeah, it's the user. So your current user on the default Kali box we gave you guys is called Kali, but what it actually is the user. So you have different users on your machine, of course, and whichever one you're currently logged in as or doing stuff as in the shell, because you can become other users in the shell, it displays that. So if I turn into a different user, I'll give you the other user. And finally, who can tell me the last, what was the result of the last command? Avsearch Python. Yes.
Shows all the Python packages, right?
Yes, correct. So what are packages? We'll get into that soon. Yeah?
I have a question, not that.
What's your question?
What's APT?
So we'll get into that in a second. I'm not sure if it's the next slide. Not quite. I'll get into that in a second, but that's a good question. So what is this apt command that we just ran? Yeah, do you have a question?
For me, it said command.found apt.
Oh, because you're on Mac. So apt, I'll talk about this first then. So what you guys just ran into was a package manager. So a package manager is a kind of special thing on Linux systems. It's kind of like your Microsoft Store in a sort of way if you guys use Windows. So basically it's a way of, basically what happens is that people out there have big lists of applications that are like pre-packaged for your particular distribution. And these packages can be applications. So for example, you can download in Discord via apt. So it's kind of like all of these common applications out there that like somebody might want on their system on Linux. You can use the apt like package manager to search it up, oh, are there Discord packages out there? And then download a Discord package onto your machine very conveniently. So this kind of bypasses the need to like go online, find the Discord installer, and then like download it and like run the installer, et cetera, et cetera. For some applications or some dependencies, this is also very useful for coding dependencies. So there's certain dependencies that you can install directly to your computer, so that and then that way it makes the process of installing like coding dependencies, like if you've ever had to import a file in C or like Python, much easier. There's a little bit of an oversimplification. Basically, you can see all the installed packages on your system using apt list in your terminal if you're running a Linux distribution that uses apt. And then sometimes you will have to kind of update the list of all packages that exist on like the package manager server on your own computer. So you can do that, update that list by running sudo apt update. And then to install some application, you can first do apt search to search like, oh, what versions of this are there? And then once you find one, you can do sudo apt install package name to install it. So earlier, since you just found all of those Python packages, once you find the version you want, you can just run sudo apt install Python, I guess 3.11, and then that will automatically, very quickly and easily install Python to your system. You can start running Python, the language, which is very useful. If you end up using Linux, this will be kind of your best friend. There's also a couple other ways you can install apps. Not for now, we don't really need to go over this, but this is not the only way of installing stuff on your system as on Linux. It's just like the most convenient if it exists. So now if we go back, let's talk about a couple other things. So files. Everything in Linux is considered a file, but the thing is that most people don't really know what this means, because like we know that files are files, but when we say everything, we do mean everything. Directories are files, processes are files. Your Wi-Fi connection, or at least a configuration for it, is a file. There are a couple of different forms that files take up, and this somewhat also goes for Windows. So for example, there's a readable text file, so that might be like your homework.txt. It might also be a binary executable file. What this means is basically it's a bunch of, have you guys ever heard of machine code? It's basically like a file that has a bunch of this machine code in it, and when you run, you can tell your computer to run the file, and then it will interpret it as machine code and run it. This is what like a lot of applications are. If you've ever run like an exe application, that is what it is. It's just a big file with a bunch of machine code on it. There's also like zip files, compressed archives, etc., etc. And the thing is that every file on your Linux systems, yes.
How does that differ to like Windows?
In a lot of senses, Windows is similar, but in certain things in Windows are not considered files, treated as files. It's a little much to get into, but remember, at least on Linux, that everything is a file. So if you want to, and the thing is that every file on Linux, your Linux system might not know what it's supposed to be. So for example, if you download some executable file, let's say you, I don't know, download Minecraft exe, that probably exists. But then like to your computer, then what you want to do is run the command chmod +x. So this marks the file as executable. And then that will allow you to like run an executable file. Additionally, there's a couple directories. Directories are also files. That's why they come up when you go to run ls. And how it works is that they're like linked to the different, they're like kind of linked so that like when you inspect one of them, it comes up as the files in that directory. So yeah, I'll cover the directories in a second. So yeah, so every file and directory in Linux is ordered in a tree. So the bottom directory, or like the top directory of the tree, like the trunk of the tree of all the directories on your system is called root, and it's just like a single slash. And then every directory in Linux, and this works similarly in Windows, is like kind of downstream of this. So for example, earlier I showed that our shell was opened to the home directory on the Larry user directory on my system. So if we went to like, we start from root, then we go to the home directory, which like holds all of the different like home directories of the different users on the system, and then we go down to like Larry down here. And as we can see, there's a lot of different default directories on a Linux system. So for example, the bin directory has a bunch of binaries. So these are like those executable files I talked about. A lot of the executable files, especially the ones that come with your system, will live in that file, in this directory. And actually all the commands we're running are just different executable files that live in that directory and that are linked, so that when we run, for example, ls, what we're actually doing is going to where the operating system figures out that ls is linked to the /bin/ls like file on our system, and then it runs that. And we can actually see that in a second. So like the file system contains all the users, all the commands, and all the system configurations as files. Everything on Linux is in this file system tree. So for example, I don't want this to roll again. If I do pod, again, pwd, this tells you like where you are right now. And as you can see, I swapped over into the folder that I keep all of my 220 code in. So right now we're in home Larry, so we're in the Larry home user directory, documents, CS220, project 1, blah, 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 blah. But if we want to find where the pod command lives, we can actually go to /cd, so cd is change directory, /bin, and we can see that this is where all of the different binary programs on our, or like the default ones, live on our machine. So if we look for /bin and then we look for pod, it should be here somewhere. So ls bin/pod. Yeah, right here. So we actually have a /bin/pod file in this directory, and that's like the actual command as an executable file that Linux runs when we want to run this command. If you do, I think where pwd actually tells you this information, or which might be. Yeah, so /user/bin. Oh, it's /user/bin, not /pod. But yeah. So now let's go back, and everybody who has access to a Unix system, open up your terminal and type the following commands into your shell, and discuss amongst yourselves like what did each of these commands do, and what you think the purpose of them are. So yeah, let's take another, what time is it? Let's take another 3 to 5 minutes for this, and then we'll come back. Yeah. Yeah.
I can swap between them. This is root.
Yes. So this is a link to your current home directory. So every user, I can talk about this later, but like every user has their own home directory, and you can reference it with tilde. So like if you did ls tilde, oh you're right there.
Yeah,
See that? But let's say you swap to root, so you're in a different directory, then you ls tilde. You can see that it actually references terminals and other ones. So it's the same thing as it's linked to the current user's home directory. So you see how like tilde, when you're in tilde /home/terminal. So it's like basically the same thing. It's like a link that's always like set. And this is useful in searches for like shorthand.
So, how come it's only showing documents downloads and pictures when there's so much more stuff?
You're on Windows.
Oh, and Windows just sucks.
Windows is different. It doesn't suck, but it's just different. Also, just like a reduced Linux distribution as well. I think those Linux distributions have worked. Yeah. Anyone else? Do you have any questions?
Yeah.
Permissions authorized /user. Oh, I guess you don't. Okay, so on your Mac, you have like
How did you find it? Oh.
basically you have permission to that folder as a user because as like a generic user, that you don't need it. You can swap into another folder and then it should let you in. Just be careful not to do anything else than what I'm doing up there because you
I put it in and just like nothing happened.
because you're on Mac. Hex dump doesn't come up.
This is at USR as a directory. Thanks. That's so useful. Now I know that it's useful. I think I'm ready to.
If you want like
I just finished installing.
maybe just show off.
Is everybody ready? Does anybody want more time to discuss?
Yeah. Okay. So yeah. Some of these commands might not have worked fully if you're on the Mac system because of what Mac ships with by default. Just so you guys know. So, is everybody ready? Does anybody want more time? Everybody good? Okay. So let's go for all of these commands and then see what they do. So I'm gonna split screen this. So we have cd/. So what happens when we do cd/ is that, oh, this is annoying. I need this. What happens when we do cd/ is that we go to this root directory. So if we ls here, this is kind of like I said, it's like the bottom directory or like top directory, depending on how you look at it, where like all directories on the system, all files on the system are in this directory or in a subdirectory of this directory. So we can see all of these fancy names for different actual folders, directories that are in this directory. So that's what root is. That's like what holds everything on the Linux system, every file. Then we can do /cat/etc/password. And oh, what is this? We just came up with a bunch of different lines. Does anybody understand, or like, does anybody have a guess as to what the file I just printed out indicates, or like means, or stores? No. All right. So, oh yeah.
The logins to different processes, like IP addresses or.
Correct. Not quite IP addresses. This is basically a list of every single user on the system, as well as some other information about them. For example, their default login shell. If we look right here, we have the Larry user. So we've got my full name, I don't know I dox myself, where my home directory is, and what the default shell to use when you log in as this user onto the system. So this is the file that contains all of the password, or not passwords, the users on the system. If we want to be extra cheeky, this is actually the, oh, permission denied, so actually. cat/etc/shadow. This is where every single password on the system is, stored in encrypted format. That's why I was comfortable sharing this with everyone. So if you want to find every password on the system for every user, that's where you go. It will typically be stored encrypted. So we can see that a lot of these, they don't actually have passwords because they're not meant to actually log in as them, but then my Larry user has a password that is, again, encrypted. Don't try to hack me. And yeah, so everything stored on Linux, including login information, is a file. Like, everything is a file. Now if we go back through, if we do ls/users pipe grep hex dump, this is what happens. ls/user pipe oops. Pipe hex dump grep hex dump. /user. Oh crap! I also don't have hex dump installed on this. Sudo apt get install hex dump. Oh crap! I'm using yum now. Sudo yum install hex dump. Sorry about that, live demos. So what I was supposed to do, and I'm installing right now, is find the hex dump program that should be in by default on all of your Kali VMs, and it will like show you where the Kali program executable or the hex dump program executable is. And hex dump is a program or like a command that you can run to spit out the contents of a file as hexadecimal. And then finally, if we do this last command, file/user/bin/who am I, we can see that this pops out. Let me make this a bit bigger. So what we see is that /user/bin. So if you guys remember from earlier, all of the commands on our system are stored as executable files in this folder. So we're looking at the who am I command that we ran earlier, and we are running the file command on it. So it's telling us, this command kind of tells us different information about the file that you feed it. So it tells us that this who am I executable is ELF64, so that's like a 64-bit executable file. It's made for x86 64 systems. It's like is linked in this way. What is for this version of Linux, etc., etc. Yeah.
How do you install the hex dump?
It's not really that important for now. I'll talk about it later. Yeah, so these are like kind of a few examples of like commands, like complex compound commands on the system. So I'm going to go into more depth about what happened in these. So I already talked about package managers, but also we have what's called users and groups on Linux. So yeah, okay. So we have what's called users and groups on Linux. So every single user on your Linux system has what is called, like it has permissions for every file on your system. So some of you guys might have run into issues, and I actually ran into issues on the big screen, of permission issues when you try to access certain directories. For example, /etc/shadow, when I tried to read it out for you guys,
because it has all the password data on your system, it's actually permission locked, because you don't want generic users to have access to that. So Linux has like a system where every user has permissions on what they can read, write, and execute. So if you type the command ls-la in some directory, let's go to my home directory and then go to documents. Why is it not autocomplete? cd documents, and then I do ls-la. This prints out all of the files on my system with much more detail. So now it doesn't just give me the name of every file in this directory, but also gives me when it was last modified, who, and this set of things. So this set of like characters. So what does this actually mean? This is basically the permissions for all of the files in this directory. So most of these are directory files, and that's indicated by this D up here. So if you start with a D when you run this command, that indicates that's a directory. And then beyond that, we have a bunch of permission bits. So read, write, so let's skip ahead a little bit. What this indicates is the user that owns the file and the group that owns the file, I believe. So since the Larry user created all of these files come up as owned by Larry. So as the Larry user, I'm allowed to access these. And that's indicated by this string of 3 sets of 3 bits, or like 3 sets of 3 characters. So if there's an R, that means the owner, I believe, I think the first set is, there's like a rule, there's like a ordering, but basically based off of what's in these 9 characters indicates what the owner of the file can, what everybody can do with the file or directory, what the owner of the file or directory can do, and also what the group that owns the file or directory can do. So sometimes you want to give permissions to a file to a whole group, but not a single user. You can also specify that. It's a bit hard to specify here because everything's in the Larry group, but let's say we go over to cd/user, and then, oops, and then this is /bin, I guess, cd/user/bin. Now, if we do ls-la, we will see that all of these files, they're not owned by Larry anymore, they're owned by root, because these are like the default files on the system, and these are not files that I made after I got the operating system with my own users. So these are owned by a different user. That's why if I try to modify one of these accounts as the Larry user, it will give me a permission denied error, because that's like a we don't want necessarily every single user on a Linux system to be able to modify everything. So that's why we have this permissions. So that's basically what the slideshow was trying to cover. And then, yeah, so you can also add files, of course, to groups. So this lets you give multiple users like permission to some file more easily. And I'll talk about this in just a second. So how do we get past this? Earlier, I did something to be able to access ETT Shadow when I realized that, oops, I'm not in an administrator. So I ran this command called sudo su. Basically what I did is that I swapped into the root user. So when you do the command in Linux called sudo, it basically tells you if you have permission to use the sudo command, it runs the command that you put into it as the root user. So it's basically, oh, I can't do this, let's have the administrator do this. This way there's like a little bit of like a stopgap, so that if you're doing something dangerous, it's kind of like you need to put in administrative permissions to do this. So, and that's what I say here. So earlier, I couldn't do cat/etc/shadow because of course that's all because that is all of the passwords. But if I do sudo cat/etc/shadow, if your user is in the sudoers group, then it will prompt you for a password to make sure you're the right person, and it will run that command. Did I type my password wrong? And it will run that command as the sudo user, so the root user, so the strongest administrator on the system. So yeah, I know it's a little bit complicated. I can link some resources in a second about just what those permissions, when we type out LSLA mean. Does anybody have any questions about this? Everybody get no questions so far? Okay, so we'll keep going for a little bit. And yeah, so, yeah.
I have a question. When you open shadow, like when you execute a shadow, what does it do? What does it display?
What we did earlier was we used the command cat. So the cat command reads out the contents of a file to your terminal. So it's like spitting out just what's on, if it's a text document, for example, it just writes out the text. What etc shadow is where your computer, your Linux OS stores the encrypted passwords for all the users on your system. So I basically showed you guys my encrypted password. All right, and then finally, to actually modify files on a Linux system, what you will want to do is to use a text editor, or if you want to like make a new file. So generally speaking, there's 3 text editors that come with most Linux systems. Most people will just pick one of these 3 and then stick with it. So there's what's called Nano. But this should be pre-installed on every single machine, but basically, let's say I want to modify a file in my user directory called joe.txt. So we can use the nano command. This opens a program, a text editor program, and then this allows me to modify the contents of this file. So I can like write gobbledygook, and then like do that, do this, do that, and then I can exit and then save. So it's like a very basic terminal-based text editor, like kind of like Notepad, but like it's all for your terminal. It doesn't require like a specialized GUI. Next up, we have Vim. I'm not going to show them all off for sake of time, but if you want to use Vim, it's kind of like what I just showed, but it makes very, very heavy use of keybinds and hotkeys. So this allows you to very quickly like move the cursor around and like do certain functionalities with just a couple like keyboard movements. So this is better if you are willing to put in the time to learn key bindings or hotkeys and be able to kind of become a power user. So like for example, in Vim, to start typing out on your page, you have to press in :Q, that's like your keybind, or :W, or no, it's I. You have to press I to start actually writing on your writing text in Vim, and then you have to press escape to escape out of that context, and then from there you can like start writing out different commands to like save, write, etc., etc. So if you're interested in like using like hotkeys to type text via the terminal, you should investigate Vim. There's also Emacs, which is kind of similar to Vim, but like also just like kind of another way to like type text, edit text files on your terminal. But of course, you can still use anything to modify files on your Linux system. It's just that everything else uses a graphical interface. So you can't run VS Code on your terminal because you need like a graphical interface for that. And then finally, some more advanced functionality. Sometimes you want to chain commands together to like get the output of one command into another one. That's what I did earlier with the pipe command when we did hexdump, for example, or a grep for hexdump. So the pipe operator, which is just like the strand, the straight line, I think it's the same button as like it's like the shift button for backslash. Will send the output of the command on the left to the command on the right. So if we run ls and then type it into the base64 command, it will take the text from the ls commands, like all of the directories or all the files on your current directory, and then run it through the base64 command, and base64 will basically like encode it into like a different format. So they'll, I'm not sure if I have it installed on my current. Yeah, I have it installed. So if I do ls pipe base64, it takes this and turns it into that string up top. So we took the contents of ls, piped it into base64 as input. So if I did like 121 base64 1231, it's basically the same as doing base64 1, blah, 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 I can't do it in like, you need a flag to do it, but like, it's basically the same as writing out the contents of ls to a file and then like passing in as if it was a file. So for example, base64 joe.txt. Yeah. Next up, we have write redirection. So this will basically write the output of a command to the file name, to a file with the name of whatever you specify on the right. So if we do ls and then write pipe aaa.txt, then we press ls, we can see now there's a new file called aaa.txt. Now cat aaa.txt. Voila, the contents of the current directory. And interestingly, it actually puts in aaa.txt as well because it creates a file before it runs ls. Finally, if you want to run multiple commands independently of each other on the same line, we can separate them out with colons. So if we do something like ls, then another command, let's say who am I, they will run both in succession, and then we'll see contents of ls right here, then the contents of, or the output, I mean, of who am I right here. So these are like a couple of like knickknacks you can do on the bash shell to chain together and like do compound things with commands. And finally, so finally, one final command I want to teach you guys before we start doing a couple exercises is the SSH command. So to get a shell into other servers or machines or whatever over the internet, like open your own terminal over the internet to another Linux machine running the SSH service, you can do this thing called SSH, Secure Shell Connection, or something along those lines. You'll actually have to eventually do this in EdLab. If you guys have ever taken 230 or are taking 198C, they have you connected to EdLab through this function, and it's basically opening a shell over a network connection. So for example, I have a server running on my local machine, but we can kind of treat it as if it's like a server over the internet. And then if I run the SSH command, what I do is I put the username of the user I want to be as in the shell at the IP of the server. And then I specify a port if relevant. And then it will prompt me for a password. Then I spend a password, I set it to password, and it will let me into the server. And now I can do stuff on this remote server, this server elsewhere in the world or over the internet, as the, in this case, root user, because I said root at 127.0.0.1. Yeah. So this was basically a very quick crash course into how to use Unix, how it works on a high level, and how to run commands on it and interact with the files and stuff on your system. So for I have a cheat sheet here. I'll probably put into Discord in a second linked. Basically, what you can do with what I just taught you is very complex stuff. So now you know how to like find all the files in a directory, and you know how to print out the contents of a file. So in theory, now with that knowledge, you can actually make a compound command of searching through all of the files on your system and for a specific string in a specific text file by compounding these commands together using the commands and then the different ways you can string them together, like piping and semicolons and whatnot. So what we have for you guys now is a bunch of challenges on our training platform, training.umasscybersec.org. So if you would like to, okay, what's it down? Hold on. Oh, you have to do not HTTP. So if you do http://train.umasscybersec.org, you will get to our training platform, and what you should be able to see is a bunch of Unix challenges right here. So I'm gonna make them all public now. So Oh, you'll do that? Okay. So in just a second, we'll make all the challenges public. So if you would like to apply some of the knowledge you learned today, just go over to the training.umasscybersec.org website, and then go to the challenges tab, and wait until they go public. So yeah, they're coming online right now, and find the challenges under Unix workshop. So what you'll be able to do is download the challenge and then interact with the file that you download to actually get a flag that you submit on the training platform for points. And this is a really good way to practice your Unix understanding and knowledge, and like all sorts of different techniques. And so now the talk is concluded, but if you would like to stick around afterwards to try these challenges out, see if you can apply these the commands to solve these, feel free to. We'll be going around giving you guys help if you want it. And then in a second, I'll go over how to solve challenge number 5 on our training platform, which involves an extra technique. So yeah, if you guys have any questions, feel free to come up and ask. And then make sure to join our Discord if you haven't already, and enroll in our newsletter if you haven't already. And yeah, that is all. But if you guys have any questions as you are doing these Unix challenges, feel free to let me know.